This conference will now be recorded.
Good morning, one and all. I'm A. Rajesh from AC department. My subject is embedded system design. So the subject consists of designing of an embedded system, the hardware part and the software part. So first we'll introduce our unit one. Unit one consists of introduction to embedded system. So in this we are covering first the objectives, introduction, definition of embedded system versus general purpose computing system, history of embedded system, classification of embedded systems, major application areas, and purpose of embedded system, characteristics and quality attributes of embedded system. So we'll see what these topics are. So coming to textbook, it is Introduction to Embedded System by Shibu KV. So this first textbook consisting of all the 5 units of your syllabus, and the reference books are Embedded System by Raj Kamal, Embedded System designed by Frank Wahed, Embedded Systems by Laila, Pearson Publications, and Embedded System Software Premier by David. So this is also Pearson Publications. So your embedded system designing is related to designing of an embedded system. So for this, first we have to know what is how it is defined. So what are its objectives? The objective of an embedded system is to understand what is an embedded system. So first you should know what is an embedded system. Then we'll give a definition for it. We'll know what are the basics of the embedded system. And we are going to see historical point of view for an embedded system. So how this embedded system evolved, that we are going to study in this topic. And as these embedded systems are going on improving from its complexity and its performance side, they are classified into various classifications, various types based on some categories. So we are going to see in this topic classification of embedded system. So in our objective is we will classify the embedded systems. Then by knowing the parameters and categories, we are also defining its embedded system properties and what are its applications and what is the purpose of the embedded system. So these are our objectives. So first, the introduction part. So as you know, in our day-to-day life, we are using many appliances, both in household appliances, industrial, and everywhere, wherever you use. In all the fields, all the sectors, we are digitized. We are using digital techniques, and all the devices are all related to embedded systems. So this embedded technology is bounding into our day-to-day life without our knowledge. So many of them doesn't know that this specific device comes under embedded technology, but they know how to use it, such as our household appliances. So you know how to use a refrigerator. What is the purpose of refrigerator? Refrigerator is used for preserving the food and some uh, uh, other material which you want to store for long time, as well as you want to make the water cool. So for this you are using a refrigerator, but the basic refrigerator is consisting of the coolant part, so some hardware, and some now refrigerators they are also having some techniques, how much temperature you can control, how much time you want to keep it, like that. So next it is washing machine. So this household appliances, washing machine is also coming under embedded technology. Air conditioner. So what is the purpose of washing machine? Washing machine is used for washing the clothes. So you are going to wash the clothes for certain time, and the time is fixed. Okay, it is depending on the manufacturer. It will wash the clothes, but the technique, how much time it will take the water, how much time it is going to wash, this all depends upon the program given to it. Next, air conditioner. Air conditioner means it is the AC which is used in household appliances as well as in industries, in software companies. So there are different ACs. Okay, what are the types of ACs? You can use household ACs or you can use centralized ACs. So what is the purpose of AC? AC is used to give cooling to the room by controlling its temperature. How it will control? It may be having room temperature maybe 38 degrees, room temperature may be 47 degrees, but you want to make the room cool. Okay, so for that it will allow air to flow into the room from the AC. Okay, so that is done by the air conditioner, and how that is controlled is depending upon the program given into its design. So now the present televisions, DVD players, and music systems. So all household appliances like refrigerator, washing machine, air conditioner, television, DVD players, and music systems, these all come under embedded technologies, and they are part of our life. And without knowing that they are part of embedded system technology, digital technologies, everyone is using them. These devices are built around an embedded system. People are experiencing the power of an embedded system. So even they don't know what is an embedded system, they know what is the power of an embedded system, because different vendors will manufacture different refrigerators, different washing machines, different air conditioners. Now certain air conditioners are controlled by your mobile, certain washing machines are controlled by your mobile, and televisions are controlled by mobile. You don't need any separate remote for them. So that is the power of the embedded system technology. Its features. What are the features? A washing machine is used to wash the clothes as well as dry the clothes. So it will dry. So cleaning, rinsing, and drying is done in the washing machine chamber itself, the stainless steel tub. And we are studying the features of an embedded system. And because of these features available, there is a large competition between the different vendors for these washing machines. So the user will see which embedded system he has to purchase, which washing machine he has to purchase. That is decided by the features provided by the washing machine, features provided by the refrigerator, features provided by the air conditioner, televisions. So these are only household appliances. So these embedded technologies, embedded systems, they are coming under household appliances. Like that, there are large number of appliances or devices or systems in the market used in all the sectors, not only household appliances. It may be industry, it may be showrooms, it may be schools, it may be colleges. So all is digitized. Your smartphone, the best example for your embedded system is a smartphone. Now everyone is using smartphone. What is a smartphone? The smartphone allows you to do video and audio call, watch television, watch multimedia, share the data. So how this is possible? It is all, the background is a processor. So you know your background knowledge for this embedded system design is a processor. So there is some processor, and I think everyone know that smartphones, they tell what is the specification. How you define the smartphone specification? The memory capacity. So there is some memory, you know, everyone know that for smartphone they tell what is, it is 3 GB, 32 GB, or 4 GB, 64 GB. So its features are, first it's memory, then it's camera, how much pixel it can, 48 MP or like that. So next it is processor, quad core processor, dual core processor, octa core processor, deca core processor. So now there is any person who is not related to embedded system also, they know from the example of a smartphone that there is something called memory, there is something called processor, there is something called camera. So these are the features of that specific smartphone. So a smartphone tells to every individual that there is an embedded technology which is consisting of a processor, which is consisting of a camera, which is consisting of a memory. So that is giving the comfort. So by being in a remote place, he is now able to enjoy television in a smartphone. So all the digital channels he can view by sitting in any different remote place. No need to switch on the television. He can view all the channels in the smartphone. He can do a video conferencing from a person who is in a remote place, maybe in some other America or Australia. So you can do a teleconferencing, multiple people can chat, can talk. So this is the features and the comfort provided by an embedded system device such as your smartphone. So in our subject, a student has to learn what is an embedded system, how we define it, what is the architecture of the embedded system, then what is the background knowledge required. So a processor knowledge. So because further a student has to design its own embedded system. So day-to-day life, we are going on adding more embedded system devices. So for that, you have to design a new embedded system from the existing one with more features. Then only the market will survive, and mankind or the people will experience the power of embedded system features, and your life will be more comfortable. And the best advantage is these embedded systems are reliable servants. What is servant? What a servant does, he does certain work. So the same work we are giving to a washing machine, same work we are giving to a refrigerator or television, and this doesn't require any identity. So an embedded system does not require any identity. It does not complain also. So how much workload you give to a washing machine, it will wash it. It has some capacity. So based upon the features provided by the embedded system, you have to decide the capacity. It will wash it, and it will does the duty. So embedded systems are acting as reliable servants. There is no identity and no complaints. And these embedded systems are unique. And what is unique means? Uniqueness means the design of an embedded system done for one system is unique, and the hardware as well as firmware is specifically designed for that application. So if you are designing an embedded system for a washing machine, its features are unique. It will only wash the clothes, and the software and the hardware. So from the knowledge of these embedded system devices, we could know that there is some software part. Firmware stands for software. So there is a program written in the memory. So based upon the program, once you switch on the embedded system, this program is initiated, and all the hardware is controlled by this software. Together, hardware and software will do some application. So other than this application software, there are two softwares: application software and the operating system. So operating system is the one which is going to control both hardware and the firmware. So there is a operating system which is going to control hardware and firmware. Firmware is the logic of software part or the application program which tells how a washing machine must operate. So washing machine must take clothes for certain time. Okay, then it has to take the water, it has to wash it. Okay, it has to dry it. So this all is written in your program. Similar, another application, if you take an elevator, a lift, if multiple people are sitting standing at different floors, and they want to switch on, they want to come your lift to that floor, what they will do, they switch on that floor button, and this elevator will decide if two persons are calling from two different floors, whether it has to go to first floor or second floor. That is depending on the program given. Okay, so if it is at a top floor, then how it stops at each floor, and it will allow the persons to enter into the elevator, and it will then it will go to the next floor. Or if it is in the middle floor, then if one person is giving input from ground floor and another person giving input from top floor, then whether it has to give. So this priority to the floors, which floor the elevator has to select and move the elevator or the lift, is designed by the application program written by the end manufacturer. End user is the one who is using the washing machine or elevator or traffic light controller or any embedded system. But the manufacturer is designing the application software, and he is telling the embedded system how it has to operate. And there is a processor which tells controls all this program. It studies the logic written in the memory, and as per that program given by the manufacturer, this processor is going to control the embedded system. So if you see the example, there is a vehicle automation system. So under vehicles, we'll consider our car. It is an intelligence embedded system because your intelligence is varying from headlamp controllers, ignition controllers, and to that of airbag control systems. So there is this embedded logic involved in headlamp controllers. So that is a part of one logic for embedded system. It is requiring one hardware and it is requiring some program to control the headlamp controllers, ignition controllers, and airbag control systems. But if you together take this, all embedded logic is part of a big logic. So embedded system can be an independent one or it can be a part of big system. So these subsystems are also sub-embedded systems. They together form your car, which is an automation system. And among this, we can give the priority. What is the priority? If any accident is occurring, what the car does? The car will first open the airbags in order to save the person. In order to save the person, it will open the airbags. So airbag control system is the embedded logic which is first given priority for the car automation system. So like this, from these examples, you could understand these embedded systems are becoming an inevitable equipment in all the fields. You have seen certain examples in household appliances like that, telecommunications, medical equipment, industrial control, consumer products. So these are all the fields they are using embedded systems. So from our general discussion, we can tell what is an embedded system now. This embedded system is an electronic or electromechanical system. So it may not be only electronic. So the result output can be a mechanical one. Result output can be an electrical one. The input can be a mechanical or electrical one. Overall, it is controlling some hardware. It is just some application. So washing machine is washing the clothes. Air conditioner is cooling the room. Refrigerator is preserving the food items for certain temperature so that they doesn't get spoiled. Okay, so we can define embedded system as an electronic or electromechanical system which is performing a specific function. And what is the common part in all the embedded systems? There is some hardware, there is some software, and software is called as firmware. This is called application software. What is the application software? Application software is going to tell what this embedded system must perform. And this application software and hardware are together controlled by an operating system. That operating system is specific to some embedded systems. Some embedded system does not require operating system, such as your toys. So there is a program written in your electronic toy. There is a hardware provided to the toy. The toy will move forward, backward, or it does rotations as per the application software. It does not require any OS. OS is required. OS means operating system is required for controlling any real-time applications. What is real-time? We are sensing the real input, and based on that, like if one missile is coming, so you have to detect that missile and you have to again give an input so that that missile is hit by your missile, or you are going to launch your own missile, or you are going to control any flight or any navigation systems. So there you require some real-time inputs. So your embedded systems classification, if you see, there is a difference that all embedded system may not use the OS. Some embedded systems will use OS, and that is for real-time applications. So one more example we'll see. Embedded systems example is your microphone, microprocessor that controls an automobile engine. So we can use a microprocessor to control an automobile engine. So an embedded system is designed to run on its own. So once your embedded design system is switched on, it will run on its own without human intervention, because there is a program written. This program is read by the processor. Processor will do whatever required, and it does the operation. So once it is switched on, a human will not interfere. Its application is all related to the program written in the tool memory, and based upon the application software, your hardware will control all the peripherals. So an embedded system is designed to run on its own without human intervention, and it may require to respond to events in real time. So if it is required, sometimes it requires that it has to respond to events in real time. So we'll just see what is example. So as I know, we defined embedded system is doing a specific function, and it is having a hardware and software. So if you see here, the first example is a smartphone, tab, pagers, car, digital camera, piano, microwave oven, electronic sewing machines, toys, weighing machines, refrigerator, modems, satellite systems. So these all are coming under embedded system applications. So we'll just go through some. So you know what is a smartphone? Smartphone is having a processor. Smartphone is having some OS. If you see, the present OS is Android. So everyone tells this is an Android version, 6 version, 7 version, 8 version. Okay, so like that. So versions will specify what is the features of that operating system. So there is some applications program, there is some OS, there is a hardware called processor, and there is an input called keypad, there is an output called display. So this is your smartphone, which is coming under embedded system. It allows you to make a call, it allows you to watch movies, it allows you to do teleconferencing or WhatsApp calls. So everything this is done by a smartphone. Then if you see the microwave oven, so microwave oven purpose is it has to keep the materials fresh by giving certain heating effect within to the items placed in the oven. So generally this is used to heat the material kept in the food materials kept in the microwave oven. So what it does is it takes some input material and gives heating effect to the food items for certain temperatures being set by the end user. So but its logic is not altered by the user. So next is the car automation system. So as we told, car, there is an ignition system, headlamp controllers, there are sensors. So if any vehicle is approaching or if you are going nearby to a wall, it is going to give a buzzer or alarm. So the input is a obstacle, based upon the input, output is a buzzer or lamp indication. Mostly it will be a buzzer indication also. So it tells that there is an obstacle coming nearby and you have to take care of your vehicle, or if accident is occurring, in case accident is occurring, it will open the airbags. So this is also an embedded system. Navigation systems, so based upon the radar input, it will make your flights to control the pilot to control its flights. Satellite system, the electronic toys, the refrigerators, sewing machines. So based upon the uh, input given, it will just stitch the clothes for a certain time limit, and that is depend by the user. So we'll see some more examples. So this is the pager or electronic video games, or this is a smartwatch. This is a traffic light controller. This is a ECG, electrocardiogram. This is a digital camera. This is metro rail. This is washing machine, DVD players, smartphone. So there are many different products which are depending on the embedded systems logic. If you see our traffic light controller, so a traffic light control purpose is it will sense the density of traffic coming on each of the sites. So a traffic lights will be placed at the um, point where two or more junctions are crossing, and based upon the traffic coming on one or the other area, it has to control the people coming on that way by giving a red signal, and it will allow the traffic in the other routes. So this is now, earlier it was time based. So a specific time you have to, the person has to wait. Then even if there is a no traffic also he has to wait. Now, depending on the density of traffic available in each of the sites, so that is the input. Output is your red, green or orange LEDs glowing. And this is also one example of embedded system. Your metro rail is an embedded system, your washing machines and smartphones. And in medical equipment, so you have in medical equipment, based upon the heartbeat of a person, it is going to control the input given to him, the temperatures or any fluids or scannings, all that is done, that is controlled. And the smartwatch, it will allow you to give a reminder calls. It will sense the temperatures nearby, and if any obstacle is also coming, it will also sense it by your smartphone and watches, and it will inform you by an buzzer or alarm. And the video games, these video games are also coming under embedded systems. So based upon the program given, so you can control the device. So as of now, we can just tell embedded system can be thought of as a computer hardware system. So you know, embedded system is a computer hardware system having the software embedded in it. So there is a hardware and you are embedding the software in it. So your embedded system can be an independent unit or it can be part of large system. So if there is a industry, big industry, there are all robots which are controlling, like if cable company, if you take, all the cables are winded on a bobbins, and these bobbins are lifted by the robots, and these robots will detect the color of the bobbin, and based on that it will place in the specific rack. So like that, there are many embedded systems in a big system. Like our automation system car, we are using a ignition system, headlamp controller and airbag control system. So thus we can define an embedded system is a system having a hardware and software and doing a specific task. So now you can design your embedded systems with a microprocessor or microcontroller based. So no need to be a microprocessor, you can go for a microcontroller. A microcontroller is a processor with inbuilt memory. And what is the unique feature? Embedded system itself is a unique. A fire alarm does only smoke detection. It will not wash the clothes. You remember that. So embedded system is as hardware and software together. It is a software and hardware. Some software is written in the memory, that is called application software. It has some OS. OS is also in the which memory? ROM. ROM and application software both are in the ROM, read-only memory, and the hardware, the processor and its peripherals are going to operate as per the logic given by the manufacturer. So we'll see an embedded system has three components. It has some hardware, it has application software, it has real-time OS. So why it is called real-time? Because it has to sense the events occurring in real time. So what is real-time OS means? That supervises the application software. So the application software is the program which tells how an embedded system must operate. But this software is supervised by an real-time OS and provides mechanism to let the processor run the process as per the scheduling by following a plan to control the logic, to control the logic, to control the latencies. So what is this RTOS? Real-time OS, which defines the way the system is going to work. So what is the purpose of operating system is it will tell how the system must operate by seeing the rules during the execution of application software. So while executing the application software, it puts so many interrupts. If this is occurring, what you have to do? So we'll take our example elevator. If a person is simultaneously pressing from first floor and third floor, and the elevator is placed in the second floor, then what is the application process tells? It has to move to the ground floor or it has to move to the top floor. So generally it doesn't move to the top floor. From second floor it moves to the ground floor. Then again after the elevator is closed, lift is closed, it will move to the third floor. So it does two instructions. One is it first moves to the first floor, then after closing the elevator door, it again moves to the third floor, because there are two inputs given, one from first floor and second floor. Elevator will not move to the third floor. So this is the execution of application software. This is controlled by your system. This is the system task, and that is controlled by RTOS. As we told, our embedded system is having a hardware, application software, and real-time OS. So if you see the small scale embedded system, small scale means those embedded systems which are defined in the initial stages of your design, and they does not require this RTOS. Only those systems which come under medium scale and large scale we are going to use RTOS. So from this background analysis, we can define embedded system as a microcontroller based, software driven, reliable, real-time control system. So an embedded system is defined as a combination of hardware and software and doing a specific task. The other way of defining is an embedded system is a microcontroller based, software driven, reliable, because it does all the tasks. So it is a microcontroller based, software driven, reliable, real-time control system. So these are the two definitions we can define. So we'll see what is the structure of an embedded system. So we are telling that there is a hardware, a software. For if you take any example, if you take your washing machine is having a keypad where you are going to insert all your clothes into the stainless tub. Then you have to give some powder, washing machine powder you have to give. Then you are going to close the door. Then you have to enter some specific time. You have to start the button. Specific time is generally taken by the design itself, but it has a keypad where you can control various parts of your design. Then once you give the power button, then you press the start button. So this is the keypad, that is the input. It will take the water from your inlet, then it washes the clothes for 2 to 3 times, then finally it dries it, and the result is output is you get a dried clothes. Okay, so how the input is, like if you take a car automation system, car is sensing an input or obstacle coming, and this ignition system, what it does, it immediately applies the brakes. Okay, or you have to apply, or it will sense buzzer or alarm it will give. So it depends upon all the features provided by the specific vendor of the car. If a vendor will give the automatic brakes, a vendor will just give an logic for by giving a buzzer alarm. Buzzer alarm gives a given, or some light is blown telling that there is an obstacle coming in front of us. So based on that, we are going to analyze the structure of an embedded system. The structure may be consisting of an sensor at the input for all the embedded systems. If you see the air conditioned systems, it senses the input temperature of the room. Based on that only, it will control the room temperature. Okay, so sensor, it measures the physical quantity and converts it to an electrical signal, which is read by the second part of design called A to D converter. So all the embedded systems will have some sensors. Sensor purpose is to detect the input and it will convert into an electrical signal. This electrical signal is an analog one. We have to convert into a digital one because our present processors are digital processors, ASICs or PLDs. So whatever the logic we are using, DSPs, anything, depending upon the embedded system design, you can use a complex processor to a small processor. So this processor requires the data in a digital form. So for that, you have to convert your analog data to a digital data. This A to D converter is going to convert your input given by the sensor into a digital signal. The input given from the sensor is a electrical analog signal that is digitized and given to the processor. Processor will store in the memory. Then once it initiates the process of logic of embedded system, it takes this data as the input. So if washing machine is washing the clothes, it will take your input. If air conditioner is cooling the room temperature, it will take the input temperature, which is stored in the memory. Then it allows your actuator to airflow. It means it will run the motors so that it will give the airflow into the room so that room temperature reduces to the temperature set by the user. Then digital to analog output. So digital to analog output converter is required because what is the processed data available in the processor that must be converted to an analog signal that is sent to an actuator. Actuator will give it to the output unit. Output unit can be a display. Output unit can be a motor rotation. So output can be anything physical. So an actuator is comparing the output given by the converter to an actual expected one, and it sets as per the approved output. So two examples we'll see. For a washing machine, the embedded system, we are telling that there is an hardware part. So the buttons, display, buzzer, electronic circuitry, these all come under hardware. Buttons, display, buzzer and electronic circuitry will come under hardware. Software part is you are having a processor, so that is called a chip, which is and another chip is a memory chip where it is holding the software, and it will drive the controls and monitors various operations possible. So this is the software part, and the mechanical components is all the internals of the washing machine, which actually wash the clothes, that is actually the stainless tub, control the input and output of water and the chassis. So this all comes under mechanical components. If you see the air conditioner system, it is also an all the embedded systems will have three parts. One is hardware, one other is software, another is RTOS. Because these two examples are household appliances, we are not using real-time OS. But if you go for flight control system, air navigation system, missile launching system, there we are going to use real-time OS because our embedded system must give the results in time and they must be deterministic. So for our example, air conditioning systems, the hardware is a remote, display, buzzer, sensors, electronic circuitry. The software is a chip which holds the software, which drives the controls, monitors various operations, and then releases the coolant. Then next is the mechanical part, the internals of an air conditioner, the motor, the chassis, and the outlet. So these all come under mechanical components. So next we'll see our classification comparison. So we are going to compare embedded system with general computing system. So everyone knows that there is a general computing system such as your desktop. Desktop is also having processor. Desktop is having an input like a keyboard. Desktop is having an output called monitor. Desktop is having a processor. So if you switch on your general computing system, it is also doing some purpose. It is also, but we are not using a general computing system for all applications. We have designed a specific system called embedded system, which looks like a general computing system, but it is unique and it is not general like your desktop systems. So we are just differentiating our embedded system with a general computing system. So your embedded system is a combination of special purpose hardware. So the hardware is special purpose. The processor designed is special purpose. The processor can be a microprocessor or microcontroller. The processor can be an application specific integrated circuit, or it can be a complex programmable logic device, or it can be a digital signal processing chip, or it can be a PLD. So we are not using normal processors. We can design a specific processor, or if it is small applications such as electronic toys, you can use a general purpose processor, but still the processor used in embedded system is a special purpose. It is meant for using only some application only. So that's why combination of special purpose hardware and embedded OS for executing a specific set of application. So the applications are not general, the application is unique and it is a specific set of applications. Washing machine will does a set of applications, air conditioner does a set of specific applications, whereas desktop will do the same routine applications. All desktop computers, they have some application softwares. You can do just programming by using your input and output peripherals. So general computing system such as a desktop system is a combination of general purpose OS and general purpose hardware for executing some applications, whereas embedded system is a combination of special purpose hardware and embedded OS for executing a specific set of applications. So next point for embedded system is it may or may not contain the OS for functioning, but general purpose, it contains a general purpose OS. What is general purpose OS? Like your Unix, Linux, they are general purpose. Okay, Unix, Linux, they are general purpose. But whereas OS for embedded system is RTOS, real-time OS, like VxWorks, like that. So all embedded systems may or may not contain the OS. The software of embedded system is pre-programmed and is not altered by the end user. But the software here, application software, Turbo C program, you have written some program for executing Fibonacci series. So that program is, again, you can alter it. So that is the applications written for generating a Fibonacci series. So that applications are altered by the end user, whereas the software written for controlling the embedded system is pre-programmed and is not alterable by the end user. So after differentiating embedded system with general computing system, you should understand that the software part is pre-programmed and it is not altered by the end user. And because it is application specific, how you decide an embedded system is, it is the requirement. The application specific requirement is going to decide its factor. Whereas general computing systems, so you have various desktop systems by various vendors. It is only the speed and the compactness of the design. So performance is the key parameter in selection of general computing system. Whereas application requirement, if you are doing the application, we can compromise with its portability, or it can be weight, or it can be memory capacity, or any hardware, anything. The application must be met by the embedded system, whereas the performance is must be good for general computing system. And because it is an embedded system, it must give some control on the power. If we are using multiple vendors, we go for power rating, which embedded system takes less power, so which is having a power saving modes, such embedded system is selected. Whereas general computing system, we don't bother about power. So we require only that our performance is done fast and our applications are done fast, so we don't compromise on the power. But here we have to control the power. Response time must be critical, or it may or may not be critical, because electronic toys, if it is doing the operation of toy operation, we are happy. It may not be time critical, but if it is a flight launching system, flight control system, or it is a missile launching system or airbag control system, that must be time critical. So if once accident is occurring, if after 10 minutes airbags are opened, it is waste. Airbag must be opened the moment the accident occurs. Initially, once the target is fixed, the missile must launch it must be deterministic. It must not miss the target. Similarly, it is time critical, whereas electronics toys are not time critical. In a similar way, general computing systems response requirements are not time critical. And the behavior of an embedded system, the behavior of an embedded system is deterministic, and it is hard real-time system, whereas the behavior of general computing system, it is not deterministic. So your desktop computer, you are using a turbo C and you have written a program. Today it is generating some data, and tomorrow, if it is may not be deterministic, means it may not be exact as generated by the in all the times. But whereas your execution behavior for embedded system must be deterministic. So comparing your general computing system and embedded system, we can tell that our embedded system is a specific hardware and a specific OS, and it is having application requirement. So the application must be met. It is tailored to soft power saving modes. It must be time critical depending on the application, and it must be deterministic. So embedded system is a microcontroller based real-time control system, time critical system, and real time. So coming to, I see in the all these topics, we just define an embedded system. So from our discussions, we know that embedded system is a electromechanical system having a hardware and software and doing a specific task, and mostly it is time critical, and mostly it is deterministic. It is exactly deterministic. But how they got evolved? Now, what are the complex embedded systems we are using? They got evolved from its prior designs. So if you see the prior designs, it is the history of embedded systems. The first embedded system designed was an Apollo guidance system, guidance computer, AGC, developed by the MIT lab. The AGC was designed on 4K words of ROM and 256 words of RAM. The clock frequency of first microchip used in AGC, Apollo guidance computer, was 1.024 megahertz. The computing unit of AGC at that time, it was consisting of 11 instructions and 16-bit word logic. It used 5000 ICs. So the design was used 5000 ICs. The UI of AGC is known as Display. Display means display keyboard, and it is similar to your calculator keypad with a large number of numbers. So this is the first Apollo guidance computer. So first they developed this one, and next once this was all the hardware part. The next embedded system they evolved is the mass produced embedded system for guiding the computer called Minuteman missile in 1961. So these embedded systems evolution began with these two systems. Then later on, once the Intel 4004 processor came, they started designing these embedded systems for all business calculators, and it was produced by the Japanese company Visicom. So this is the background history of embedded system. From this class, we could understand embedded system is a unique system. It is having hardware and software. It does a specific task. Mostly the task is real time. If it is real time, it must be time critical and deterministic. If it is not real time, it may not be deterministic. And these embedded systems may or may not use OS, but they are different from general computing systems. So students, from this definition of embedded system class, we could understand how we have defined an embedded system. We'll cover the topics in our another class, next class. Thank you.